December 2023 UGC Net Electronic Science Question Paper Solutions Part 5, that is from question number 101 to question number 125. First question. This question is related to multiplexer, demultiplexer, encoder and decoder. We know that multiplexer is a combinational logic circuit with 2 power n inputs, 1 output and n selection lines. Demultiplexer is the inverse of multiplexer with 1 input, 2 power n outputs and n selection lines. Similarly, decoder and encoder are inverse to each other. Decoder is a combinational logic circuit with n inputs, 2 power n outputs and 1 selection lines. Encoder is a combinational logic circuit with 2 power n inputs, n outputs and 1 selection line. So statement A, an 8 input multiplexer can be implemented using any 4 variable function. So number of variables required is log of capital N base 2. So that is log of, given here, 8 base 2. Log 8 base 2 is 3. So 8 input multiplexer can be implemented by using 3 variable function. So statement A is incorrect. Statement B, a 3 to 8 line demultiplexer. So 3 inputs, 8 outputs, 3 to 8 line demultiplexer or decoder can be implemented by using 4 variable function. It is wrong. Can be implemented by using 3 variable function. Statement B is incorrect. Statement D, a 64 input multiplexer can be built by using 9 8 input multiplexers. Statement C is correct. So here there are 2 stages. In stage 1 we will use 8 by 1 multiplexers, 8 by 1 multiplexers. Therefore total number of inputs will be 64. All the outputs of stage 1 multiplexers are connected as input to a 8:1 multiplexer. Here it is an 8:1 multiplexer. So now in stage 1 8 multiplexers, in stage 2 1 8 by 1 multiplexer. So the total number of multiplexers required is 9 multiplexers. To implement 9 8:1 multiplexers are required to implement 64 by 1 multiplexer. Correct answer is statement C is correct. Statement D, a 6 line to 64 line demultiplexer can be built by using 9 3 line demultiplexers. Statement D is correct. Therefore correct answer is option 3. Only C and D are correct. So let us see some more points related. Implementation of 32:1 multiplexer using 8:1 multiplexer. 8:1 multiplexer using 2 by 1 multiplexer. This is how to implement 8:1 multiplexer using 2:1 multiplexer. Next question. Consider the following statements regarding registers and latches. Statement A, registers are made up of edge triggered flip-flops, whereas latches are made up of level triggered flip-flops. Statement A is correct. Registers are edge triggered, whereas latches are level triggered. Statement B, registers are temporary storage devices where latches are not. Statement B is incorrect. Registers and latches both are temporary storage devices. Statement C, latch employs cross-coupled feedback connections. Statement C is correct. Statement D, a register stores binary word whereas latches does not store. Statement D is incorrect. Both registers and latches store a binary word. Therefore correct answer is option 2. A and C are correct. Next question. Consider the following statements. When two signed numbers are added, an overflow is detected from the carry into most significant position. Statement A is incorrect because in signed binary numbers, usually in 2's complement format, a overflow does not depend solely on the carry in the most significant bit. Overflow happens only when the result of addition cannot be represented in available number of bits. So statement A is incorrect. An overflow is detected from the carry in the most significant position. It is incorrect. Statement B, an overflow does not occur if two numbers are added or both negative. Statement B is incorrect. An overflow may occur. An overflow may occur. Let us see an example for this. 1001, that is minus 7, 1001 minus 7. If these two bits are added, the resultant is 10010 overflow. Extra bits gets discarded. So discarding the fifth bit, the result is 0010, which is plus 2, and this is completely incorrect result. Thus, addition of two negative numbers can overflow if their sum goes beyond the range of representation. Statement B is incorrect. A overflow does occur if two signed numbers added are both negative. In statement A, when two signed numbers are added, an overflow is detected from the carry in most significant position. It is not detected. Statement C, if the carry in the if the carry into the sign bit position and carry out position are not equal, then overflow condition is produced. Statement C is correct. Statement D, full adder is a logic circuit with 3 inputs and 2 outputs. Statement D is correct. Full adder is a combinational logic circuit with 3 inputs and 2 outputs. The outputs are sum and carry. Correct answer is option 4. Next question. In 8051 microcontroller, ACAL absolute call instruction has a following interpretation. It is an 2-byte instruction. ACAL is an 2-byte instruction. Statement A is correct. It is an 3-byte instruction. Statement B, it is wrong. ACAL is an 2-byte instruction. ACAL is an 2-byte instruction. First byte is opcode. Second byte is lower 8 bits of 11-bit address. Only 11 bits are used for the target address. Therefore, address range is 2 power 11. 2 power 11 is 2048 bytes, that is 2 KB. ACAL can only call subroutines within the same 2 KB block. Next, both ACAL and LCAL push the 16-bit return address to the stack in the same way. Hence, there is no difference between ACAL and LCAL in terms of saving the program counter to the counter on the stack. Next is, for ACAL, target address is restricted to 2 KB, and for LCAL, target address can be anywhere within 64 KB. Now see the statement C. The target address of a subroutine must be within 2 KB because only 11 bits of 2 bytes are used for the address. Statement C is correct. Statement D. There is no difference between ACAL and LCAL in terms of saving the program counter on the stack. Statement D is correct. Statement E. The target address can be anywhere within 64 KB. It is not 64 KB. The target address can be anywhere within 2 KB. Statement E is incorrect. Therefore, correct answer is option 1, that is A, C, D statements are correct. Next question. Question number 105. In the following 8051 assembly language program, move A, 25H, move B, 78H, multiplication of A and B. Now, the multiplication operation of A and B instruction is used to multiply the contents of register A and register B in 8051 microcontroller. Multiplies 8-bit unsigned values in register A and register B. The 16-bit result is stored as follows. Lower 8 bits are stored in register A upper 8 bits MSB stored in register B. The overflow is set to 1 if result is greater than 255 and carry flag is always cleared after multiplication. Carry flag is always 0. Overflow is set to 1 if result is greater than 255, else overflow is 0. Carry flag is always cleared after multiplication. That's the first thing we need to remember. And the second thing is overflow flag is set to 1 if result greater than 255. It is set to 0 if result less than 255. The contents of A is 25H. The contents of B is 78H. 25H in hexadecimal is equivalent to 37 in decimal. 78H in hexadecimal is equivalent to 120 in decimal. Now multiply this 37 and 120. The resultant is 4440 base 10. That is 1158 hexadecimal. Lower bits are stored in register A. LSB bits and MSB bits are stored in register B. Now the carry flag is option statement B is correct. A contains 58H and B contains 11H. Now statement C is correct. Carry flag is always reset and overflow flag is 1 because the resultant is greater than 255. So it is greater than 255. Therefore overflow flag is set to 1. Overflow flag is set to 1. So correct statements are B and C. Correct answer is option 3. Question number 106. A conventional magnetron has an anode voltage of 26 kilovolts, beam current of 29 amperes, magnetic field B naught 0.336 Weber by meter square, radius of cathode cylinder 5 centimeters, radius of vane is 10 centimeters. We need to calculate the value of cyclotron angular frequency. Cyclotron angular frequency omega c is q b naught by m. The formula for angular frequency is q b naught by m, where q is charge 1.6 into 10 power minus 19, b naught magnetic field is 0.336 Weber by meter square, and m is mass of electron 9.11 into 10 power minus 31. So on calculation we will get Wc is 5.91 into 10 power 10 radian per second. Statement B is correct. Cyclotron angular frequency omega c is 5.91 10 power 10 radians. Now cutoff voltage. Cutoff voltage Vc is 1 by 8 q b square Ra square minus Rc square whole square by m. Ra minus Rc. Radius of vane is Ra 10 centimeters 0.1 meter. Radius of cathode 5 centimeter 0.05 meter. 0.1 whole square minus 0.05 whole square. Ra minus Ra square minus Rc square is 0.0075. 0.0075 whole square. On substitution we will get cutoff voltage Vc is 139.59 kilovolts. 139.59 kilovolts. Statement B is correct. Statement D is correct. Therefore correct answer is option 2, B and D only. Next question. For a wave motion in perfect dielectrics, the following condition is given. A material is lossless. Statement A. Material is lossless. Perfect dielectric properties are lossless, isotropic, homogeneous. Statement A is correct. Material is lossless. The material is lossy. Statement B is incorrect. The medium is isotropic. Statement C is correct. The medium is non-homogeneous. Statement D incorrect. Statement E is correct. Therefore, correct answer is A, C, E, option 1. Perfect dielectric properties are lossless, isotropic, homogeneous. Lossless means no conduction, no energy dissipation. Isotropic, same properties in all directions. Homogeneous, same material properties throughout. Uniform properties throughout. Therefore, correct answer is option 1. Next question. For a parallel plane transmission line with two conducting plates of conductivity sigma, thickness T, separation of D, and dielectric parameters epsilon, mu, and length B dash for B greater than D, parallel plate transmission line. The inductance per unit length is L is equal to mu D by B, where D is the separation, B is the length. Similarly, the capacitance of parallel plates per unit length is epsilon B by D, capacitance per unit length. Conductance is sigma B by S. For parallel plate line, characteristics impedance Z0 is square root of mu by epsilon D by B. So these are the formulas. Correct answer is option A. Statement A is incorrect because inductance L is equal to mu D by B. Here it is B by T is given, so it is wrong. Statement A is incorrect. Statement B is correct. Statement C, conductance is correct, and statement D is also correct. Correct answer is option 4. Question number 109. The disadvantage of coaxial cable is, so coaxial cable support higher bandwidth than twisted pair cable. It is wrong. Statement A is incorrect. Statement B, coaxial cable is lightweight. Incorrect. Because in the question they have asked disadvantages. So supports higher bandwidth is advantage, lesser weight is advantage, relatively expensive compared to twisted wire cable. So this is a disadvantage. EMI resistance. EMI resistance is an advantage. In the question they have asked disadvantages. Disadvantages. Relatively expensive compared to twisted pair cable and does not vary at high frequency. Statement E is correct. Therefore, correct answer is option 2, CE only. CE are the disadvantages, A, B, C are the advantages. Next question. Question number 110. Statement A, multimode fiber is less noisy than single mode fiber. Statement A is wrong. Single mode fiber is less noisy. Single mode fibers generally have lower losses than multimode fiber. Statement B, the bandwidth of step index fiber is 50 MHz. So statement B is correct. Statement C, the graded index fiber has theoretically infinite bandwidth. It is correct. The graded index fiber reduce model dispersion significantly and sometimes considered to have very high or theoretically infinite bandwidth in ideal conditions. Statement D, the step index fiber has numerical aperture of 0.2 to 0.5. Statement E, the numerical aperture of graded index fiber lies in between 0.46 to 0.99. Statement E is incorrect. Therefore, correct answer is option 2. B, C, D statements are correct. Question number 111. Which of the following statements are correct with respect to Routh stability criterion? Statement A, this stability criterion applies to polynomials with only finite number of terms. Statement A is correct. Routh criterion is valid for polynomials with finite number of terms, that is characteristic equation of finite order. Statement B, when this criterion is applied to a control system, the information about absolute stability can be obtained directly from the coefficients of characteristic equation. Routh criterion uses only coefficients of characteristic polynomial to assess absolute stability without finding roots. Option statement B is correct. Statement C, the Route's stability criterion tells whether or not there are unstable roots in the polynomial equation without actually solving for them. This is the main advantage of this criterion is determining roots locations in terms of stability without solving the equation. Statement C is correct. Statement D, RH criterion, Rouse's criterion is not related to system stability. It is related to system stability. Statement D is incorrect. Therefore, correct answer is A, B, C, option 4. Next question. Given firing angle of converter alpha 1 is 60 degrees, alpha 1 is 60 degrees, firing angle of converter to alpha 2 is 120 degrees, and Vm maximum voltage or peak voltage is 120 volts, frequency is 60 Hz, angular frequency omega is 2 pi f, that is 2 pi into 60, 120 pi radian per second is the angular frequency. Inductance, the value of inductance L is 40 millihenry. We need to calculate peak circulating current. The formula for peak circulating current is 2 root 2 Vm by omega L 1 minus cos alpha 1. Substitute the values here. 2 root 2 Vm is 120, omega L is 120 pi into 40 into 10 power minus 3, 1 minus cos 60. Cos 60 is sin 30, its value is 1 by 2, 1 minus cos 60 is 1 minus 1 by 2, its value is 1 by 2. On substitution, its value is the value of peak circulating current 11.2539 amperes, approximately it is 11.25 amperes. This is the value of peak circulating current. Also, we need to calculate the peak current of converter 1. Peak current is the sum of load current and peak circulating current. Now, load current IP is root 2 Vm by R. The formula for the load current IP is equal to root 2 Vm by R. Root 2 Vm is 120 and the value of resistance given is 20. It is 6 root 2 8.4852 ampere. 8.48 ampere. Then peak current of converter 1 is load current 8.4852 and circulating current 11.25 ampere. Its value is 19.735 ampere. 19.735 is a peak current and circulating current is 11.25. Correct statements are A and D. Correct option is 1. Next question. In induction motor, the following statements are given. Let us see some theory points related to this induction motor. In a three-phase induction motor, synchronous speed Ns is 120 F by P. The starter produces rotating magnetic field, that is MMF, and the velocity of this field is called synchronous speed ns, where f is frequency, p is the number of poles. One cycle 360 electrical degrees, the mmf wave travels one complete wavelength. For a two-pole machine, this 360-degree mechanical degrees are twice the pole pitch. So mmf wave travels two pole pitches per cycle. Given statement A, the mmf wave travels during one cycle of current the distance twice the pole pitch or wavelength. Twice means 2. Statement A is correct. Statement B, for a given pole pitch and frequency, the velocity of traveling field kept varying. For a constant frequency and number of poles, the synchronous speed is constant. If synchronous speed is constant, the velocity of mmf wave is also constant. So statement B is incorrect. Statement C, the mmf wave travels during 1.5 cycle of current, the distance twice the pole pitch of the wavelength. Statement C is incorrect. mmf wave travels two pole pitches per one cycle. For 1.5 cycle, it corresponds to 3 pole pitches. So statement C is incorrect. It is not 2 here, it is 3. In statement B, it is not varying, it is constant. Statement D, for a given pole pitch and frequency, the velocity of traveling field is constant. So statement D is correct. Correct statements are A and D. Correct option is 2. Next question. There are number of distinct advantages of digital storage oscilloscope as given below. Statement A, the waveform can be stored is digitalized. So the waveform stored in digital storage oscilloscope is digitalized. Statement B, the waveform is stored in digital memory. Statement B is correct. Statement C, the stored waveform can be displayed as and when required. Correct. Statement D, the cost is reduced when compared to conventional CRT. Statement D is incorrect. The cost of DSO, digital storage oscilloscope, is quite higher when compared to conventional cathode ray oscilloscopes. Correct statements are A, B, C. The correct answer is option 4. Next question. Read the following statement with respect to Wien bridge. Wien bridge is an AC bridge used to measure frequency. Statement A is correct. It is an AC bridge used to measure frequency. Statement A is correct. It is a DC bridge to measure amplitude. Statement B is incorrect. Wien bridge is an AC bridge. Statement C, it is used as frequency determining element. Wien bridge. Statement C is correct. Used to determine the frequency. Statement D, it is a band pass filter. So Wien bridge it is not a band pass filter. It can act like a notch filter. In oscillators, the bridge forms a frequency selective network. Twin T or bridge T. These Wien bridge networks are preferred to used as an notch filters. Therefore, correct statements are A, C and E. Correct option is 4. Question number 116. MOD FET, mod FET, modulation doped field effect transistor. This device is known for having two-dimensional electron gas. Mod FET is a device known for having two-dimensional electron gas. Next, MOSFET, metal oxide semiconductor field effect transistor. This structure involves PN junction placed back to back. So MOSFET, PN junction placed back to back. Solar cell fill factor. Solar cell fill factor. Fill factor of a solar cell is a measure of how closely cell output resembles an ideal power source. essentially indicating the quality of cell's performance. This fill factor indicates the quality of cell's performance. The higher fill factor means cell is more efficient in converting light into energy. Next, JFET, junction field effect transistor. So JFET is an voltage controlled oscillator. A matches to 4, B matches to 3, C matches to 2 and D matches to 1. Therefore, correct answer is option 1, A4, B3, C2, D1. Next question. Annealing is used for crystal restoration. A, it is 4. Scaling relates to packing density, ensuring device is protected and compact. Sealing. Sealing related to packing density. Ion implantation. It is a process. This process is a method of doping or introducing impurities into semiconductors. Ion implantation is related to doping. Oxidation. Typically used for isolation for forming insulating layers like SiO2 in integrated circuits. So oxidation is isolation. Correct answer is A4, B3, C2, D1. Option 4 is a correct answer. Next question. Properties of discrete time Fourier transform. Statement A. It is related to frequency shifting property. So frequency shifting property x of omega minus omega naught. Next, statement B. It is related to differentiation in frequency. So differentiation in frequency, n into x of n is j d by d omega capital X of j omega. Statement C. It is related to differencing x of n minus x of n minus 1, that is 1 minus e power minus j omega x of j omega. C, it is 1. Delta of n minus n naught. Delta of n minus n naught is time shifting e power minus j omega n naught. A2, B4, C1, D3. Correct answer is option 2. Next question. Voltage series feedback. In voltage series feedback, input resistance increases, output resistance decreases. Input resistance increases by 1 plus A beta times. Voltage shunt feedback. Voltage shunt feedback, output resistance decreases. In voltage shunt feedback, output resistance decreases. Current series feedback, input resistance increases, output resistance increases. So current series feedback, output resistance increases. Current shunt feedback, input resistance in current shunt feedback, current shunt feedback, input resistance decreases. So input resistance gets decreased. A4, B1, C2, D3. Correct answer is option 4. Next question. EP, ROM, PLA, generic array logic and PIL. EPROM, erasable programmable read-only memory, is a memory device where AND gate is programmable, output permanently hardwired. PLA, programmable logic array, both are programmable. Generic array logic, AND gate permanently hardwired, OR gate is programmable. PAL, AND gate is programmable, OR gate is fixed. EPROM, erasable, programmable, read-only memory. AND gate is permanently hardwired and OR gate is programmable. So for A it is 4. PLA, programmable logic array. Both AND gates and OR gates are programmable. PAL, programmable array logic. AND gate, programmable. OR gate, permanently hardwired or fixed. Generic array logic. Generic array logic, AND gate, programmable, output permanently hardwired but may be taken through register or tri-state gate. For C it is 3. A4, B2, C3, D1. So correct answer is option 3. Next question. It is related to addressing modes. Move BX, AX. The data is transferred between two registers. So register addressing. Register addressing. Move, move AX, 50H BX. Register relative addressing. An offset 50H is added to the content of BX to form an effective address. For B it is register relative addressing. Next, move AX, BX, that is effective address BX. Register indirect addressing. Register indirect addressing. Move AX, 2000H, that is direct addressing. Direct addressing. Correct answer is A3, B1, C4, D2. Option 3 is a correct answer. So addressing modes in 8086 are immediate addressing mode, register addressing mode, direct memory addressing mode, register based indirect addressing mode, register relative addressing, base index addressing, relative based index addressing, and implied addressing modes. These are the different addressing modes in 8086. So register addressing mode is given. Source and destination registers can be one of the source or destination can be one of the 8086 registers. Move AX, BX, move AL, BL. Immediate addressing mode. 8-bit or 16-bit data can be specified as a part of instruction. Memory addressing mode. And then different ways of specifying offset. Direct memory addressing, register indirect addressing, effective based addressing, indexed addressing, base index addressing, and finally string addressing. These are the different addressing modes. Next question. Microwave transistor, heterojunction bipolar transistor used at microwave frequencies. So microwave transistor is HBT, heterojunction bipolar transistor. Field effect transistor can be used in CCDs, charge coupled devices. Next, indium phosphide diodes are used in transferred electron effects. Transferred electron devices INP, indium phosphide diodes. Avalanche transit time devices read diode. Which is a type of avalanche transit time device? Correct answer is A4, B1, C2, D3. Option 1 is a correct answer. Next question. White noise. White noise has flat spectral density and is referred to as Johnson noise. So white noise is, other name for white noise is Johnson noise. RMS noise voltage is inversely proportional to root T, square root of time. RMS noise voltage is inversely proportional to square root of time. Modulation. Modulation reduces antenna height. The advantages of modulation is to reduce the antenna height. Power in DSB SC, double sideband suppressed carrier modulation. PC mu square by 2, where mu is a modulation index. Correct answer is A4, B3, C1, D2. Option 1. Let us see some more theory related to this question. White noise is a type of random signal which has equal intensity at different frequencies, giving a constant power spectral density. It is also called as thermal noise or Johnson noise in electronic circuits. RMS, root mean square noise voltage, is a statistical measure of magnitude of the noise signal. Statistical measure of magnitude of noise signal. It provides effective values of fluctuating noise voltage, and it is important for quantifying noise level in electronic systems. It is often inversely proportional to square root of bandwidth or time. Modulation is a process of varying one or more properties of high frequency carrier signal in accordance with the low frequency information signal. This effectively reduces the antenna height or dimensions of antenna. Next is double sideband suppressor carrier modulation. The total power P is equal to Pc into mu square by 2, where mu is a modulation index. Option 1 is a correct. Next question, electrical resistance volt per meter, that is equivalent to ohms, volt per ampere. For A it is 4 ohms. Thermal resistance centigrade per watt. Thermal resistance is centigrade per watt. Time constant is product of RC. Next, rate of heat transfer is watt. The amount of heat energy transferred per unit time, that is watt. Correct answer is A4, B1, C3, D2. Option 1. Option 4. Question number 125. Potentiometric device resistance, it is related to transistors and their applications. This potentiometric device is a type of transducer that converts displacement into an electrical signal. Application is potentiometric device application is displacement. Resistance hygrometer measures relative humidity. Dielectric gauge measures thickness. Moving coil generator measures velocity. Here, potentiometric device, it is used to measure displacement. Resistance hygrometer used to measure relative humidity. Dielectric gauge to measure thickness. Moving coil generator to measure velocity. Correct answer is A3, B1, C4, D2. Option